Hello, my name is Steve Bowler, and in this video I'm going to be configuring standard access control lists. And what we're going to do is be configuring two routers. We're going to set it up between two routers, and we're going to use two loopback interfaces to simulate our customer networks. And then we're going to set up an ACL on router 1 to show you guys how standard access control lists are configured. Okay, so I'm back here. So I'm going to go back into router 1 now and console in. What we'll do is we will run RIP version 2 as our routing protocol between the routers. So we'll go into global config. We'll change the host name to R1. Then we'll do the no exec timeout under the line console 0. Then we're going to go into the fast Ethernet interface on router 1 and assign the IP address of 172.16.1.1 with a /30. No shut the interface. Then we're going to configure our loopback interface. And our loopback on router 1 is going to be 192.168.1.0. I'm sorry, 1.1/24. Then we're going to go ahead and specify RIP as our routing protocol version 2. And then we're going to do no auto summary. And then we're going to be running RIP for network 192.168.1.0 and network 172.16.1.0. So the network, so that'll encompass our loopback and our connection fast Ethernet to router 2. So let's go into router 2 now and get it configured. And as you can see here, the network between router 1 and 2 is 172.16.1.0/30. We'll go under global configuration mode here. We'll give it the host name of router or R2. Then we'll go to line console 0 and do a no exec timeout, which is good practice within GNS3. That way your session does not expire. And your CPU, sometimes if you don't set this, your CPU utilization will jump up after you set your idle PC value and you're at a console and you let it just go for a while. So now let's go under our interface loopback 0. We'll give it the IP address of 192.168.2.1/24. Then we'll go under our fast Ethernet, give it the IP address of 172.16.1.2, and that's going to be a /30. Again, fast Ethernet 00 on both routers are connected to each other. We'll go under RIP version 2, and we'll go under RIP. We're going version 2. We're going to do no auto summary. We're going to also specify our networks to run RIP on, which are 192.168.2.0. and then also network 172.16.1.0. So now if I do a show IP protocols, we can verify that we have RIP running on the router. You can see the networks that we're running RIP for. You can see the interfaces. So if I do a show IP route now, well, looks like we're still just seeing the connected interface between the routers. We do a show IP interface brief, and there is our problem. As you can see, our fast Ethernet 00 was shut down on router 2. So if I go to router 1 and do the same thing, just make sure I have both of my interfaces up, which I do. So now if I do a show IP protocols, or I'm sorry, show IP route, well, we see the one network. But there now we see the RIP network. We just have to give RIP. RIP is a slow routing protocol, so we just have to give it a minute for RIP to propagate its updates to its neighbor. So now you can see I can ping on router 1 if I do a ping to router 2's loopback 192.168.2.1. As you can see from router 1, I can ping router 2's loopback. So now what we're going to do is create a standard access list here. Actually, let's make another loopback interface on router 1. We'll call it loopback 1. We'll give it the IP address 192.168.100.1/24. And we'll go under RIP. We'll advertise this network into RIP. If I go to router 2 and do a show IP route, now you can see the 100 network learned via RIP. So if I try to ping the 100, now I have reachability. So let's go ahead and put that up here so we know that that network is there, that 192.168.100. So let's loop back 1. And then down here, this is our loopback 0. So what we'll do here is we're going to be showing you how to set up an access control list and how to verify that a standard access control list has been successful. And we're going to be doing some monitoring, some basic capabilities. So say we want to block the loopback 0 interface on router 1. How we do this would be to create a standard access control list will allow us to block based on source IP address only, not on destination. So say we wanted to block the loopback 0 interface on router 1 from getting to the loopback 0 interface on router 2. We go under router 2, we'll create an access list, and for standard access lists through 1 through 99, so we'll go access list 1, and we'll just do what we can see from here is you can either deny or you can permit packets, or you have to remember that with access control lists there is an implicit deny all at the end of all ACLs. What we want to do here is we want to block the source network of 192.168.1.0 on router 1. So we'll do access list 1 deny, then we'll do 192.168.1.0, and then here it's going to ask us for, we could just hit enter here, or you can specify your wildcard bits. So right now the wildcard bits are pretty much like a subnet range that you want to block. So in order to specify the whole /24, we're going to do 0.0.0.255. Say we wanted to block, say with the /25, we would put there 0.0.127. Or say it was a /26, it would be a .63, and so on. So again, we're not going to explain too much of that. But right now what we're going to do is we're going to block that whole /24, which is the .255. And we're going to log this, so that way we can see packets being denied, and we're going to see that in our log when we look at the ACL using the show command. So that's a good feature with the log message there, or the log option. So if we ping from router 1, if we try to ping the 2.1, we can ping 2.1 just fine. So we're going to deny packets from the source. Again, with standard ACLs, you can only deny based on source networks. So we're going to deny here the 168.1.0. We don't want to allow that to have access. So basically we're going to allow all this traffic from entering our router on R2. So what we're going to do on R2 is we just hit enter there, we go ahead and go exit. So now we have to specify what interface to apply it to. So if we apply it inbound on the Fast Ethernet 00 interface on router 2, that traffic is going to be denied to anything on router 2. Just using a standard access list, that's what we're going to see here. Anytime it sees the source IP of 192.168.1.0, anything within that /24 subnet, it's going to deny all that traffic, regardless of whether it goes to the loopback 0 interface or we could even create another. Here we'll create another loopback here. We'll put it in a 200 range on R2, just to show you how this policy works, how the standard ACL works. If we go under router 2 and go under the interface, if we go under interface loopback 1, give it the IP address of 192.168.200.1, the /24 subnet mask. What we'll do is we'll go under RIP. We have advertised this network. We'll have to go under RIP and advertise this under that network into RIP. So now what we need to make sure is that router 1 has connectivity to this. And as you can see here, we are learning of the 200 network. So if I go ahead and try to ping it from router 1, you see that I have connectivity. So now what we're going to do is, regardless of where we put this ACL inbound on R2, it's going to filter all the source traffic of 192.168.1.0 regardless of which subnet it's trying to reach on R2. So if we go under interface Fast Ethernet 00 on router 2 to apply an ACL, we're going to do the IP access group and then specify our access list that we just created, which is access list 1. So here you can also, if we put a question mark, you can see that you can do inbound or outbound. And the packets that we're trying to filter are sourced from router 1. So those packets will be coming inbound into R2. So that's why we're going to use the in option. Now to do this, if I do a ping to the 2.1 and do a repeat of 5,000 IP access group 1 in, once I apply this, you see right away that we are now getting on deliverables on R1 on my ping. So that ACL went into effect right away. If I do a show access list, you can see here that I have the deny statement here for access list 1. Actually, you know what we forgot to do? There's an implicit deny all at the end. We forgot to add another sequence in the access list. So we'll go ahead and do a access list 1 permit IP and then any and then log. And that should be it. Okay, now you can see here that this traffic is going through, and I'll tell you why that is in 1 second here. So right now this traffic is not being blocked. You're probably wondering why. Well, what I'm going to show you here is a real cool tool, and we're going to show you it is called IP route cache flow. And what it's going to allow us to do is see real-time traffic traversing through the router. and you can enable this based on a per interface basis on the router. So we're going to go under interface fast Ethernet 00. If we do a IP route space cache flow, and then if I do a on R2, we can actually monitor this traffic as it's flowing through our router. If we do a show IP cache flow, what you can see is the real-time traffic going through our router. You can see the source. We're seeing here the traffic from source Ethernet fast Ethernet 00 with the source IP address 172.16.1.1, which is router 1's fast Ethernet 00. We're seeing it trying to reach 192.168.2.1, which is our loopback 0 interface on R2. And so what you can determine here from this, that the source IP address is 172.16.1.1, and we can also see the destination of 192.168.2.1. So we're only seeing one-way traffic. So if I go under interface loopback 0, actually, now I don't think you can do that on a loopback interface. You can't see the IP cache flow on a loopback interface. So, sorry about that misleading information there. I apologize for that. We're not going to be able to see traffic on a loopback interface with the IP route cache flow command. If we go to router 1's interface fast Ethernet 00 and do a IP route cache flow on it, if I do a show IP cache flow, actually let's generate some traffic here. We'll just do a ping of 5, and now if I do a show IP cache flow, what we can see here is traffic from the source Ethernet of fast Ethernet 00 with the source IP address of 192.168.2.1 going to the destination of 172.168.1.1. So what you can see here with the IP route cache flow command is that we can monitor real-time traffic as it passes through your interfaces. You can also match just on an IP address with the pipe to include command here. So if I do a show IP cache flow pipe to include 192.168.2.1, so there you can see filter based just on a single IP address, because as you can see, if we have IP route cache flow on a bunch of interfaces, you're going to get a lot of traffic flow through there if you have it on a lot of your interfaces. So we can isolate or filter that traffic by just filtering it based on an IP address, a specific IP address. We can also do a show IP cache flow just on, using just the 2. We don't even have to specify a number on the 4th octet. So what we can see from this example is that the access list, if we do a show access list, you can see here that it's not denying anything from the source loopback interface of router 1. We can see a bunch of permits, but we're not seeing anything denied. So what happened is we forgot to source our pings from the loopback 0 interface on R1, and we can see that with the IP route cache flow command right here. Remember, the cache flow command showed the source interface of router 1's fast Ethernet 00, or the outbound interface on R1, which is 172.16.1.1. that's why you're seeing all these permits. So you can also see source, port, and destination port as well if you're trying to filter based on port traffic or seeing different types of port traffic. So it's a great, again, the show IP cache flow command and IP route cache flow are great for troubleshooting issues. If you're trying to troubleshoot complex routing issues, I would just suggest doing or using IP route cache flow and show IP cache flow as troubleshooting tools. They're very powerful tools to help you troubleshoot. So again, one-way traffic is usually not good. You want to see bidirectional traffic. So it's a very powerful command. Again, you have to remember that it's enabled on a per interface basis. And so what we want to do now is we want to ping from R1. We're going to ping the 2.1 from router 1. We're going to ping loopback 0 on router 2, and we're going to source this from our 192.168.1.1 IP address. So we just do that by doing a ping and then following up with the source and then the IP address that we're sourcing from. And now what you can see here, now you're seeing in the log entry here on R2 that's saying that it's denied traffic from the source of 192.168.1.1. If I go on R2, if I do a show if I do a show access list now, what you can see here is that we now have matches on our deny statement, which is sequence 10 under our access list 1. So again, we had to source the pings from the network that was being denied in the ACL to be able to see those matches. If we were to ping this of the source of 100.1, as you can see here, it's going to go through just fine. If we do a show access list, you can see that the incremented over 5 packets on the permit any. So again, you have to remember the standard ACLs will filter based on the source network range, not on the destination. If we go into R2 and do an access list 1, say we do a no access list 1 and then try to recreate it, do access list 1 permit. Actually, in this case, we're going to deny 192.168.200.1, which is our loopback 1 interface on R2. We're going to deny all this traffic and log our entry. And then we're going to follow it up with a access list 1 permit any. So again, if we do a show access list on router 2, so now what you can see here is that we have a deny. So we're going to, if on router 2, if I go under global configuration and do a no access list 1 and then do access list 1 permit any log and then go under here and do a no access list 1, just give me 1 second here, I'm trying to figure out here what I'm going to do. We'll do an access list 1 deny 192.168.200.0. So all the traffic from our 200 network and then we're going to do a permit any. So if I do a show access list now, you should see the 200 network being denied, and we're permitting everything else. So what I want to show you here, standard ACLs are filter based just on a source network, and I'm going to show you this here. With that being said, now if I ping from router 192.168.200.1 and I source it from my loopback interface here, 192.168.100.1, now based on the logic that router 2, or the ACL, the standard ACL on R2 blocks just on source network, this traffic should be able to go through, because the source traffic in this scenario, the source traffic is 192.168.100.1. So in this scenario, the destination is the 200 network, and the source is the 100 network. So if I go ahead and ping, you can see that traffic has passed through, no problems. So we do have matches on the permit, and we don't have any matches on the deny. So if I do a show IP cache flow, actually, sorry, let me see here what we can do. If we do a show run interface fast Ethernet 00, you can see that we still have our ACL command inbound on fast Ethernet 00 on router 2. Actually, all you're seeing here is RIP version 2 traffic, multicast traffic, 224.00.9, so don't worry about that. So if I do a show IP cache flow again on router 2, you can see we're seeing traffic sourced from the 192.168.100.1, which we did on router 1, with the destination of 192.168.200.1. So again, this traffic is being permitted because in this scenario there's nothing with the source of 200 network that router 1 has. So on router 1, remember, we're sourcing from the 100 network. Okay, so that's pretty much it. That wraps it up on the standard access control list. They're pretty simple. They're one of the first types of ACLs that you learn. Again, they're going to block based on the source network, and that is what we just went through proving to you. So I hope you guys have enjoyed this video, and we're going to do some more videos on ACLs. This is our first ACL lab, just to give you guys a feel for access control lists and how to do standard ACLs. And we also wanted to show you guys how to use the IP route cache flow command. Again, remember that it's enabled on a per interface basis, and that you can use that to monitor traffic that is flowing through your interfaces. And you just want to make sure that you're seeing bidirectional traffic using the IP route cache flow command. And it's a great troubleshooting command. Again, I've used it a lot in troubleshooting, and it's just a great command. It really helps you see where the traffic is coming from, sourced from, and going to. So again, it's a great command, and this lab again will help you out It'll help strengthen your fundamentals on standard access control lists. And again, once again, we just proved that standard ACLs use the source network to filter on, not the destination. So I hope you guys have enjoyed this video, and I hope you will watch the next one that I make. Thanks for watching.